Okay, so let's talk now about series. This is from your homework 2.2 series worksheet. Number 1 says expand the following series and their partial sums. So we need to know what a series is. A series is really just the sum of a sequence. And this is sigma notation. This is the Greek symbol sigma. And it tells us to add everything in this series starting with the first term. So this is the starting term. All the way up to the fifth term. So this is the ending term position. So what I really need to do here is then calculate these things. If my index is 1, then that's what I'm going to start for my I. So notice that you'll see I here. Sometimes that'll change. Sometimes that'll be an N or a Z. But it's really the same thing as we did when we did sequences before where it was an N. So I'm going to start by plugging in 1 because I'm going to go from 1 all the way up to 5. So I have 7 times 1, and then I'm going to add that to 7 times 2. And I'm going to add that to 7 times 3. And I'm going to add that to 7 times 4. And then I'm going to add that to 7 times 5. And there I am. So let's go ahead and calculate these things. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. Now if you want to add those all together, you can get out your calculator, you can use your brain power, however you like, but you'll get 105 for your ending. So we expanded the series right here. This is the expansion. So this part is the expanding where we actually wrote out the sums. And then we actually found the partial sum, which was 105. So those are the two parts of this answer. Next, we're going to write the sigma notation for the finite series. Okay, so we have two types of series. We have a finite series and we have an infinite series. And a finite series means that I'm going from a starting point to an ending point, and that's it. The sequence is done. It ends. If infinite series would keep going on and on and on. So when we have a finite series, we're just going to add up the terms in those finite series. But all we need to do here is write the sigma notation. So let's start out by writing down sigma, which is our nice symbol like that. And let's go ahead. We are going to just see here, we're going to write it up here for our I is 1, 2, 3. And let's see if we can find a pattern. Well, if my I is 1, it's 1. If my I is 2, it is 1/2. If it's 3, it's 1/3. So notice that I'm really, if we were to write this 1/1, that we are going up by 1 in our denominator. So if we're going up by 1 in denominator, and this is our last term, because this is a finite series, then our last term is the 12th term. Because notice that our n is the denominator, or our I is the denominator, our number. So now I can go ahead and write the sigma notation. On the bottom I have the starting term. So I'm going to go ahead and write I is equal to my starting term, which is 1. On the top I write my ending term. I'm going all the way to the 12th term. And now I have to write the rule. We'll take a look at our numerator of our fraction. The numerator of the fraction never changes. It is 1. The bottom of the fraction we said was our I. So we can just go ahead and write this as 1/I. Now if you choose to use n or I, that doesn't really matter. You can use them interchangeably. This is going to be equal to, the sigma of n equals 1 to 12. those are the same. As long as your variable is consistent within your rule and your index down here, there's no problem. So there's your answer. Writing the sigma notation for this series. Now let's try one for an infinite series. Same idea. We have to figure out what our place values are. So if we use n this time, we're going to go 1, 2, 3, 4, and see if we can find a relationship between the place value and the actual value of that term. So the first term is -1, the second term is -2, the third term is -3. So to me it looks like here we're just making it the opposite of the term place value. So let's go ahead and write this out in sigma notation. Because this is an infinite series, I start with my index at 1 because that's my first position, but I don't ever stop. So I'm going to go ahead and put the infinity sign above because that means go on forever and ever. And now I'm going to write my rule. Well, I said it was going to be the opposite of my n. The opposite is used with a negative symbol, so we use the opposite of n, and that's my rule. Oh, my n disappeared. But if you have any questions on writing in sigma notation or finding partial sums of a series, please see me or Mr. Daniels and have a fabulous time with your homework.